basically like an extension of 110. So we're going to be talking about the same topics, but now we're going to try going backwards. Okay, what I mean by that is now we're going to be looking at graphs of absolute value functions, and we're going to be interpreting their equations based on the graphs instead of the other way around. But before we do that, we're still going to look at a few more examples of graphs of absolute value functions, and we're going to look at ones that are stretched and compressed. So let's go ahead and do that. So our goal today is to address what an absolute value function is and identify key features of absolute value functions and derive their function values from the graph. So I am looking at example 1. It says here we have an absolute value function. Y equals -2 times the absolute value of x plus 3 minus 2. So above it, I'm going to write standard form, and we're going to analyze it. So what is my a value this time? Very good, and it opens downward. Thank you. What's my h? Very good, and k? Good. So that would make my vertex -3 and -2. And we're going to make a table. I'm just going to do 3 on this one. What's going to be in the middle of my table? Good, -3 and -2. Your vertex is always the center of your table, okay? What's a number smaller than -3? Good, and bigger? You got it. And we're just going to plug these x values in to my equation. So -4 plus 3 is -1. Absolute value of -1 is 1. 1 times -2 is -2. -2 minus 2 is -4. We're going to do the same procedure for the -2. -2 plus 3 is 1. Absolute value of 1 is 1. 1 times -2 is -2. -2 minus 2 is -4. You always want to look for that symmetry to make sure you didn't make any algebraic errors. Then we're going to plot these points. We have -4, -4. We have -3, -2. And we have -2, -4. So -4, -4 is 1, 2, 3, 4. 1, 2, 3, 4. And then we have our vertex -3, -2. And lastly, we have our last point, which is -2, -4. So we are going to connect. Literally, it's always during this period with you guys, like thunderstorms. I know. Sorry. So now that we have our graph, does anybody notice what looks different about our graph here than the others? Yeah, it's narrower, right? Anybody have an hypothesis on why that's the case?
Because it's going up by 2 rather than like 1 unit.
Good. So yeah, your a value is no longer 1 or -1, it's 2 now. So as the a value gets further from 0, I'll say further from 0 because it can also be negative numbers. As my a value gets further from 0, it makes my graph narrower and narrower, okay? So my axis of symmetry is what? X equals -3. Does my graph have any roots? No roots. My domain is always all real numbers. Now we're going to look at increase and decrease. Okay. So my graph is decreasing from -3 to +infinity over here. over here. 3 to +infinity. 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 3 to +infin And my graph is increasing from negative infinity to negative 3. Now we're going to look at our range. So the range are all the possible y values my function will ever take on. So if I highlight this right here, this is where my range is occurring. Okay? And in this case, whenever you have a negative a value and your graph's flipped, your range is always going to be from negative infinity to something. Okay? Negative infinity, and it goes up to your k value. It's always included. Okay? Now, for end behavior, are both sides of my graph going down or both sides going up? What do you guys think? Both going down, so these are both negative infinity. Do I have any questions so far? Okay. Now we're going to move on. So now we're going to look at this absolute value graph. What's my a value here? And it opens which way? How did I know it's going to open upward? Good, because the a value is positive, exactly. And what's my h going to be? Good, and my k? Positive 2. So this is going to be 3, 2. So looks over here. Okay. Now, for your table here, let's see. I'm only going to do 3 just because we don't have a lot of room. That's honestly why I'm doing 3. Could do 4 as well. Your middle value is always your vertex. And what's one value lower than 3? And bigger? Good. I'm now going to plug these values into my equation and evaluate. 2 minus 3 is negative 1. That becomes a positive 1. 1/2 plus 2 is 2.5. And over here I'm going to do the same thing. When I do the algebra, I end up with 2.5 as well. And you'll notice the symmetry once again. Now I'm going to plot these points. So this is 2, 2.5, and this is 4, 2.5. So 2.5 is going to be like right here, and 2.5 is going to be like right here. So when I graph that, it's going to look something like this. And what are your observations about this versus the last one? Good, it's stretched out wider. So when the a value is a decimal, when your a value is really close to 0, what do you notice happens to your graph? Good, it gets wider, right? It's stretched out. Gets flatter. So what's my axis of symmetry here? X equals 3. Do I have any roots? No roots. My domain is always all real numbers. Now we're going to look at our decrease. So it's actually going to change around this time. So I have 2 sides of my graph. And now this time, the pink is actually the decreasing part, right? And the yellow is the increase. So let's look at it. So from negative infinity, going up to 3, my graph is decreasing. And then at my vertex, which is a point of, we call it a critical point in math, which is a point where your slope changes basically. We go from 3 to positive infinity is where it's increasing. And now we're going to talk lastly about range. So range is everything my y value will take on, which is this whole section up here in orange. Like that. So in this case, my range is starting and going upward. So it's going to be from square bracket 2, because 2 is my lowest y value, going up to positive infinity. Remember, your range will always include your k value, whether it be on the front end or the back end of your interval. And is my graph going up or down on both sides? Up. So this is positive infinity. Positive infinity. Questions? Alright. So now we're going to talk about doing the opposite. So we've been creating graphs based on equations. Now we're going to create equations based on graphs. So it starts out pretty similar. My graph opens which way? Upward. Good. We actually aren't going to be able to find our a value quite as easily, but everything else is pretty visible. So what's my h value here? Yes, 4. And my k value is? -3, which makes my vertex 4, -3. Okay? Now we're going to look at our axis of symmetry, which is right here. And what is the equation of my axis of symmetry? X equals 4. My domain is always all real numbers. And now we're going to look at increase and decrease. So my graph is decreasing down here on this side. So if we look at it in terms of different colors, my graph is decreasing over here. And it's increasing over here. Yeah. So my graph is decreasing from -infinity to 4. And my graph is increasing from 4 to positive infinity. Does this graph have roots?
Yeah.
Yes, it does. And what are they?
3 and 5.
Good, 3 and 5. I'm going to write them in forms of an ordered pair. So 3, 0, and 5, 0. They can also be written as x equals 3 and x equals 5. Just read the question and see what they're looking for. And now we're going to determine our range. So range are all the values that my y coordinates will ever take. In this case, my range is starting from -3 and going to positive infinity. So you might start seeing the trend now, but if your graph is going upward, your range is going to end on positive infinity, and if your graph is going downward, it's going to start with negative infinity and end on a number. So you'll kind of start seeing that pattern. And behavior, up or down? Up. So the only thing we're missing right here is the a value. And this is the most difficult one to find. So I'm going to kind of look at this. I want to zoom it in to show you. So there's 2 ways to find the a value. You can do so using algebra, or you can do so using the graph. I'm going to show you both ways, and then you're going to pick whatever you prefer. I won't tell you what I prefer. So you're going to pick the vertex on the point line. Okay, you're going to look at the vertex, and then you're going to pick another point on the graph. Okay? And you always want to do this on the right side of your graph. So the part where, see how it's a V? You always want to look at this section of the graph. If you pick the other side, it's still going to work. And I'll kind of show you how that's going to look. But what you're going to do is you're going to count the slope. So remember, slope is rise over run. So we're going to calculate the slope of this line. So rise is 1, 2, 3 units. So you go up 3 units and over to the right 1 unit, right? And is my a value going to be positive or negative in this scenario? So your a is here is 3. And that's how you find it. You use slope. Now that's how you do it using the graph. Now I'm going to show you how to do it using algebra, okay? Because there are times when your graph is going to look too complicated for you to do this, so I want to make sure you have all the tools possible for you to be able to solve this. So, this is a little bit more tedious, but it's not too bad. So what you're going to do is you're going to take the standard form of the absolute value function, okay? And the first thing you're going to do is you're going to plug in for h and k. So that's going to be y equals a times absolute value of x minus 4 minus 3. So I plugged in for h and I plugged in for k. You guys with me so far? Now the next thing you're going to do is you're going to pick any point on your graph other than the vertex. I'm going to pick this point right here, which is 5, 0. You're going to pick any point on the graph other than your vertex. Once you've picked that point, you're then going to plug that point in for x and y in your equation over here. So I'm going to plug in, that's going to give me 0 equals a times 5 minus 4 minus 3. So all I did was plug in for x and y. Now you're going to solve for a, like it's a variable, okay? So this is 0 equals 5 minus 4 is 1. Absolute value of 1 is 1. 1 times a is 1a or a. And then how would I solve for a here? Add 3. So a is 3. So see how we get the same answer two different ways? So you pick whatever you want to do. And then lastly, to get the actual equation of your line, you're just going to put it all together with this information. So you're going to take the standard form, and you're just going to plug in for a, h, and k. So it's just going to be 3 times the absolute value of x minus 4 minus 3. And that would be the equation of your absolute value function. So that was a lot. Does anyone have any questions? Was it straightforward enough, or? Sometimes I don't know if I'm explaining things in too much detail or not enough, so just let me know. You guys ready to try another one?
Yeah.
Alright, let's try the last one. Alright, so we're looking at an absolute value function, and it's opening which way? Good, it's opening downward. We don't know a yet, but we definitely know the vertex, and the vertex is? Good, negative 1, 2, which means my h is negative 1 and my k is 2. We can find the axis of symmetry, which is x equals negative 1. It's always x equals h. My graph is decreasing from negative 1 to positive infinity, and my graph is increasing from negative infinity to negative 1. My roots, we're going to get there. We'll wait on that one. My domain is always all real numbers, and my range, in this case, is going to be negative infinity up to 2 hard bracket. My end behavior, both sides are going down. Good. So, what's the problem with roots? Yeah, I can't see the other one, but we know it exists, right? Like, everybody can tell that it's there. We just don't know what it is. So, in this case, we're going to have to use algebra to obtain that other root, and I'll kind of show you how to do that, okay? So, before we can do that, we're going to find a, okay? So, are you guys good with me just doing the graphical part of a, or do you guys want to see the algebra too? Graphical? Okay. So, let's look at the a value. So, we always pick 2 points. I'm always going to use the vertex, and then wherever else my graph falls evenly on a coordinate. And I'm going to use rise over run. So my graph is going down 1 unit, which means negative, right? And it's going over 1, 2, 3 units. So that means my a value here is negative 1/3. And we knew it was going to be negative? How did we know our A was going to be negative? Good, it opened downward. And I also knew that my A was going to be a fraction. Anyone know how I knew that?
It's so wide.
Exactly, it's so wide. I knew it was going to be that case, right? So now that I have that information, I now know the equation of my absolute value function, and it's negative 1/3 absolute value of x plus 1 plus 2. Does everybody understand how I got that? Remember, for the h value, you always have to change its sign in the formula. Now that we have that information, I now want to show you, kind of refresh, blast from the past of last week, how I can find the roots of this. So since I can't look at the roots and know what they are, I'm going to have to use the equation. So we have to find the zeros, also known as roots. That means I have to plug in 0 for y. Remember doing that? So that's going to be negative 1/3 absolute value of x plus 1 plus 2 is equal to 0. And do you guys remember the first step in solving for an absolute value equation? We have to get the absolute value alone, by itself, subtract 2 on both sides. I end up with negative 1/3 times x plus 1 equals negative 2. I'm going to get rid of the 1/3 by multiplying both sides by negative 3. That cancels out my 1/3. And that gives me x plus 1 equals 6. And now, you guys remember what you have to do now? We have to write it out 2 ways. Tell me you guys are remembering this a little bit, right? Okay, I'm like, does everybody know what I'm talking about? Okay, so then you write it the positive way, so you write it as x plus 1 equals 6, and then you write it as negative 1 times x plus 1 equals 6. Subtract 1 on both sides, and that's x equals 5. Well, we already knew that one was a root because we could see it, right? So we already knew about this root. It's this root we didn't know about. So I divide both sides by negative 1, and that gives me x plus 1 equals negative 6, which gives me x equals negative 7, which is my other root. So that's how you could find the root that's missing. Now, if you kind of think about it critically, there is another way to get the root. You could make a table for the graph, right? And just keep going until you get to a 0 for a y value. And that would also work. So you can be kind of, what's the word? Creative, I guess? Intuitive, yeah. Alright, did I go over that part too fast? Okay, I just went quickly because we've already done it. But that's all I have for you today. You guys have 40 minutes to do your homework today. So you have a good chunk of time to get the homework done. Classwork, technically. And just let me know if you have any questions.